Hi everyone! I want to take you on a time-traveling journey back to the ancient ocean that helped build the Niagara Escarpment and much of the Saugeen Bruce Peninsula. Often when I talk about how the Niagara Escarpment was formed, I sort of oversimplify it. I say, oh, there was a coral reef and it solidified into rock. And there was a coral reef and it did solidify into rock. It's a really cool story actually to think about this ancient barrier reef system, just like we see a barrier reef off Australia today, the reefs that form just offshore of a land base. You think about the Great Lakes, they're in a big basin. And if that basin filled with salt water along the edge, it would form a barrier reef. And when we talk about this reef, it didn't form here in the Northern Hemisphere. The land we're on physically was below the equator in a tropical sea. And so that basin filled with salt water had a coral reef in it that was tropical, very hot climate. And that coral reef was somewhat similar to what we see today. It had corals, it had snails, it had crinoids, which are kind of like a starfish type relative. It had clams, it had trilobites and sea scorpions, which were kind of like trilobites. They had segmented bodies, but they had more predatory structures to them. And the squid at the time weren't soft-bodied, but in these kind of long shells or twisted shells that protected their soft parts. And now they've evolved to almost have squids have a little tiny thing inside them called the pen, if you've ever seen one cut open, but for the most part they're soft and squishy. So it was kind of a few similar animals, but a few animals that were looking a bit different, and a few animals we don't even have today, like the trilobites. And a lot of animals, like there'd be no birds calling in the sky, there's no mammals on land, there's no reptiles that have evolved yet. This is 420 million years ago, so Earth looks very, very different. It's different temperature, different oxygen levels, the moon's a touch closer, totally different time. But what's amazing is a lot of the organisms haven't changed a whole lot, and we'll see that today. So when I talk about this coral reef, I feel like I'm oversimplifying it, because it was a coral reef, but there would be patches in between the reef where it was mud, mud flats, sand flats. Out off from the barrier reef, there would have been little pinnacle reefs forming, so reefs that just form from the bottom of the ocean floor like a cone. And you can actually see these various environments when you look at the Niagara Escarpment today in certain parts. So there's one particular spot that I know of that you can walk along the shore and you can actually see that you're in a mud flat because there's just brachiopod fossils all over. And that particular species lives kind of in the oozy muck that's like off from the reef itself. And then you keep walking and all of a sudden you hit this wall where the rock rises and there's coral fossils all over the place. And so you're actually seeing the reef come up. It's like I'm snorkeling along the mud flat and I see the reef kind of coming up into my view, but it's all just rock now. But you can tell based on the fossils that are in those rocks and kind of the way the rocks look and whether they're lumpy or not, what part of the reef they might have been. And there's a really cool part of the Guelph Formation, which is predominantly sort of on the top or to the west, top of the cliffs or to the west of the Saugeen Peninsula, and outcrops in other spots down the Niagara Escarpment as well. And in this formation, there's areas where there's these big beds of giant mollusks, and they're super cool. Mollusks that's a scientific term for a group of animals that all are sort of commonly related. It includes snails, clams, and squids and octopi. It also includes things like chitons and some other critters that are very similar to some of the snails and squids and things like that. But we don't see those as commonly. We're all used to snails and clams and squids, so we can keep our head at that. And some of these animals get a lot bigger than they seem to on some of the reef structures. So let me see here if I have an example. Here's and I have all these fossils were given to me by friends who had them on their private property. So these weren't ones that I've collected from anywhere out in the wild. They were ones that were gifted. So this is a great exterior cast. So it's actually the outside of a clam shell. And you can see those little lines going out. Those are like the growth lines. You see that on clams today. So here's a modern day clam with those growth lines. It's kind of just the same thing imprinted into the rock. So that's an exterior cast, but here's an interior cast of one. So this is like the meaty part of the clam. The inside of the shell got filled up. The meaty part would have rotted away, but that hard shell would have sort of sat in the mud. And so you can see it's like the inside of the shell sort of perfectly preserved. And here's the matriarch of the clam world. Look at the size of this one. It's literally the size of my head. It's absolutely huge. And you can see a lot of really good detail of the hinge, where the hinge was formed. So clamshells join on this beautiful little hinge of teeth. And you can see that just clear as day on this particular example. You can also see some mud cracks, so where the mud cracked as it dried, which is really cool. You can see on this one, not on this one, you can see on this one some little worm burrows. So this is an animal that would have been probably burrowing at the time. So that's what you'd call a trace fossil. So it's not a fossil of any organism, but we know there was a little kind of worm burrowing through all that muck, to create that pattern. And what's really cool about this big one is it was sitting on, this is the surface of the rock with pitcairn in it that are formed by chemical weathering. And so you, underneath that pitcairn was sitting this giant clam. It's just amazing. And there's other critters like this snail, nice tall spired snail. Some snails are kind of flatter. There's quite a few of these mollusks that live in this kind of environment. Another really cool one is this giant squid I've got. Let me just set down the clam. So this squid is would have been particularly large. You can see how big it was around. And it comes in several pieces. So there's an exterior cast. You can see little sections of the shell there. Here's the these actually fit together somehow or another. There we go, like a puzzle. So there's this big squid interior cast. So the shell would have been hollow, like an ice cream cone, and then this is kind of an interior part of the structure. But look at it, it looks like a perfect like drill core, but that's just the squid's body. So you can imagine this squid would have been, if we sort of extrapolate out, it would have probably been at least a meter and a half, and they got bigger than that. There's fossils of some squid in the area that are even larger than that. But it's pretty cool to see all these kind of mega mollusks, and these probably would have been living in a bit of a muddier environment, in between or like offshore from those coral reefs. So it's cool that we see these fossils full stop. I mean, they're fun to look at, but what's really cool is that we can walk through these environments. So when we're walking through the rocks, we can be in this ancient oozy mud flat. We can be in this ancient, you know, sandy lagoon. We can be coming up upon a tall pinnacle reef, coming up to a smaller section of the barrier reef that extends through the landscape. So even though all of this was taking place 420 million years ago, we can walk through these environments today and still enjoy them. It's like a dry land snorkel. Super cool.